Okay, in a second here, I'm going to get started with the stream. Okay, cool. So in a second here, I will get started. Let me just post the link. Okay, gonna wait for the link to get posted. Okay, it looks like it's been posted. In a second, I will start. Okay, cool. Actually, let's close out of this and get some music playing. Okay, cool. So let's start. So today, as I will probably for like the next week, I'm going to continue working on the static bug finder, particularly with the code iteration. So the point of what I'm trying to do is right now the static bug finder, it can look at a piece of code and like flag it such as like, hey, this is a variable memcopy call, could potentially be a bug. Issue with doing that is on any decently sized target, that's going to return a ton of different results, and like if we're lucky, 95% of those you won't care about, or like it won't actually yield anything. Um, yeah. So for that, what I'm trying to do is have code iteration where this bug finder can actually iterate through the code paths and build a context such as like, hey, the size argument is passed through these checks, or the destination or the source, it's incremented in a loop somehow. And we can then leverage that context to then better evaluate if a potentially vulnerable piece of code, if it's more likely to be a bug or less likely. That way we can hopefully sift through a lot of those like false positives a lot easier. For this, so let me turn this down so I can think. Okay, cool. So for how I'm doing this, the code iteration so far was I just had a function here. Well, first, I'll take a function that I wanted to iterate through. I would turn it into a pcodes array where like and iterate by the index, so iterate through the first one, index 0. One thing that I needed to take into account for was branching, both conditionals and direct branches. For direct branches, I would just, well, for both, I would have this function called resolve index where I would get the branch address from the p code, pass it to resolve index, and that would give me the p code that I'm trying to iterate to. For branch, I would just set the new index equal to whatever that p code index is. For the current branch, or the conditional branch, since it can stem off in two separate ways, I would then also make a recursive call down one of the branches and then have the current branch extend down the other way. That way I would cover the code path if the, well, no matter what happens with the conditional. What I'm finding is this process is a little bit more complicated than I initially intended. So moving it over to a separate class that way, hopefully it makes it a bit simpler. And that's what this code iterator class is for. Currently it's just basically nothing. This is just some sample code. But yeah, let's get started hopefully designing a better one. For this, let's do, what are we going to need? We're going to, code iterator. Well, for here we have a hash set of scene indices. So we're going to need that. we won't need this string high. Hash set integer scene indices equals new hash set. Yes, this code is on GitHub, however, it's currently on a private repo. If you guys want, I can open source it, but the code isn't in a presentable state right now, more to say, or more or less. So cool, we have the scene indices here, which is a new hash set. This is going to keep track of the indices that we've seen so far. I am storing this as a hash set that's specific to the code iterator, since there might be multiple code iterators and I want each one to keep track of that. Hash map. Okay, a few things. Right now I'm going to have a code iterator. It's going to be specifically for an individual function. Right now I'm not going to have the code iterator be that it can iterate the data path through multiple different function calls and function layers. So that will simplify the problem a little bit. We can have pcode op pcodes. This is going to be the pcodes for the function. What else? Looking here. Okay. Think we will also probably need the function that we're going to analyze, and of course the calling function. So that function func to analyze. Okay, cool. Which of these is going to be passed in as input? We will of course need pcodes. Pcode, well, we can get that from the calling function. So we really just need the calling function to analyze. Probably a few other things, but I'll figure that out later. So where does that leave us? We need to first set this dot calling func equals to calling func. This dot function to analyze equals function to analyze. Let's construct the pcodes. How does this work here? Pcodes equals get pcodes. So we have a function here called get pcodes. Let's take a look at it. Only called in two different spots. I'm just going to, since I don't think we'll need this in the main Phalanx file, I'm just going to copy it over to code iterator. We no longer have need of that. So I'm going to do this dot pcodes equals get pcode ops. I'm going to change this. Right now it takes the reference as the input argument. I'm going to change it to just the calling func. So yeah, that makes sense. We will need decompile func. I'm going to do phalanx.decompile function. That, looking through it, it looks like it should work, but let's try running it. Another thing that we might need to do is we might need to also import all of the Ghidra parts. So first error, forgot a semicolon there. Cannot find symbol. Pcodes. Pcode mappings. I'm gonna comment out all of these lines since we're shouldn't need them with this new model. Okay, we have some issues here. A lot of issues. Line 3 cannot find symbol. Okay, yeah, we need to import the Ghidra stuff. Also going to import all of the Java stuff. Later on, I'll figure out like what libraries I actually need, but for now, let's just get this working. Line 19. Accidentally put a 0 there. This should work now. Line 64, what's wrong here? Cannot find symbol. Oh, get P codes. Calling function, let's try it now. Cannot be referenced from a static context. What is the decompile func? So we tried calling just in order to get the function we call decompile func. What we might want to do for simplicity's sake is right now just pass in the high function as an argument, because the decompile func, or the process of decompiling a function requires that we set up a decompiler in the code. Right now that's done in Phalanx. However, might be a bit weird to actually have it also work. Well, we could do it something like this. Let's see, does this work? We will need to comment out this line in order to get this working. Just having there so we can just test if this works. What I'm trying to do is I might be able to just pass the actual Phalanx object that's running as an argument to the code iterator and then store it there. Cannot be up. Cannot find symbol. Okay, no, that isn't working. So for now, I'm just going to pass it as an argument to the code iterator constructor. So let's do that. Oh, also need these. I need the arguments. Func to analyze. High function. And let's get this. Let's edit this argument list to be the high function. Okay, let's try this. Let's see if this works. Okay, that did appear to work. Good. So we're able to get the P codes from here. Now, let's go through and So this constructs this dot p codes and this dot hyphen is equal to high function. Excuse me. Function. Let's also define the high function. And let's also make an integer for I, which represents the index that we're going to be iterating through. So, and also let's turn this into a private method. Cool. So next, let's actually make a function which will actually handle the iteration. Iterate code path. So, and also let's start this off with this dot I equals 0, since this is supposed to just instantiate the object. Okay, cool. And let's iterate while I is less than this dot pcodes dot length. This is going to look fairly similar to this right here. So we can pcode. We're going to need this. Actually, this is going to be pretty much this extremely similar, so I'm just going to copy and paste this function. Okay, cool. So what's going to change from here? Pcode op pcodes equals this dot pcodes. Just doing this here for simplicity's sake. Int I equals this dot I. This is going to be, we have the code here for the seed indices. So, current pcode equals, yep, that seems right. We will need the function to actually resolve an index. So, okay, that is one thing. We also need we'll need the get branch resolve index methods. Excuse me. Just going through here looking for anything else we might need. Okay, cool. Let's get those two functions. So we have get branch address, which is right here. So let's just copy and paste this over. And we will also need resolve index, which is right here. So, okay, we have these two functions here. So those should work. Now, the next thing, I'm going to comment out this conditional branch since I don't have the actual replication for the two different code paths working just fine right now. But let's just run this and see if it works. It's an error. Line 795, which is where it's calling new iteration. No class found. Let's see, is an issue with takes 3 arguments. We provided 3 arguments, calling function, high func, and function to analyze. Challenge, no class def found error. Okay, so this is a bit weird, I'm not sure. Maybe we just wipe out the arguments? Is that what the issue is? I doubt it, but let's try it. Oh, I see what the issue is. Issue is this line right here, invalid method declaration. There's an issue in code iterator which is preventing it from reading it properly, so when this tries to import code, since it doesn't import properly, it doesn't see anything from it and crashes that way. Public, we forgot it. Where is this? Iterate code. I forgot a return type. For now, it's just going to be a void. I will have this iterate code path eventually, like, iterate some sort of data structure that models the context I was able to get from iterating through the code path, but that's for another day. Cannot find symbol, code iterator line 86. What's on line 86? Or it can just be high function, high func equals this dot high func. Problem solved right there. Get address from offset. I will also need that function. Let's go ahead and grab it. Line 48, there's an error, return current program. So it's not, okay, I see what the issue is. It's needing the current program in order to run this current program that is a variable present to the class that, or the FileNext class that is actually running. To solve this, I'm going to look at the Ghidra Java docs for the current program, see what the data type is for it. It is a Ghidra program. From Ghidra program model listing, Ghidra program model listing. Okay, so we should have it. I'm just going to add a 4th argument to the code iterator constructor to actually be able to pass that. And let's see if that works. The current program equals current program. We should be able to change that to that. And then we go down here and switch this to current program. And like that, let's see if this fixes the problem. No, it did not. Forgot to actually make the variable in the class for it. Let's try this now. Current P code, no, this should be current program. Let's try this now. P code, line 119 of code iterator, so down here. Accidentally put one too many P's there. So let's try running this now. Line 134. Yeah, this could just be a lot of me just fixing errors since I basically just copied and pasted it. P code mappings. We are going to need that. I can generate that in the constructor, so let's go ahead and do that. It is going to be a hash map. So let's go ahead and define that here. And in the constructor, we can go ahead and make it this dot pcode mappings is equal to get pcode index mappings. What is in this function? Can we just effectively just move it over? Yeah, pretty much we can do that. Let's put that here, and we can do this dot pcode mappings. Pcode mappings equals this new hash map. We will need to change that there, and since it's directly editing the hash map related to the object, we can just change it over to a void. Okay, cool, so that's working. That should, and we also need to add this to the constructor. So you can do get pcode index mappings. And we don't all need this, we could just do pcode op pcodes equals this dot pcodes. Okay, that should work. Let's see. There's probably going to be other problems. Okay, that worked just fine. And did it iterate though? No, it did not, but we did not call the iterate path function. So let's go ahead and try to call that and see what happens. Code iterator, new iterator dot iterate code path. Let's see what happens. Okay, we can see it went until the branch instruction, and then it branched over to here, and then continued on. Okay, that's pretty much what we expected it to do. Now we need to actually deal with the C branch, the other conditional branch. Now, for this, what I'm thinking of having iterate code path do, not return, like let's say the data structure that's going to model like a context, I'm just going to call it context. It's not going to return a single context, it's going to return a context array, maybe an array list. Reason for that being is that how I'm imagining dealing with these code paths in terms of actually returning the result is effectively I just have an array of them, and every time I make this like recursive stem off into another code path, I just take that code, that context that returns, and just append it to an array, and then I can return the array listing. These are all the various different contexts that is possible for this function to be called under, and then I can just iterate through all of those contexts and then analyze it that way. Now, for this, First off, I'm not right now. I'm not going to worry about actually returning the context data structure because I'm not even like populating it right now. But I do need to worry about first getting it started with like iterating down the new path. Now for this, we don't need the inputs. We get the branch address, we resolve the index. Primarily, we need to clone 0. We do need to actually clone it properly. So for this, we could, how can we do this? I'm going to make a function that's called private code editor. It's going to return another code editor, and it's going to say make branch clone, and this function will actually handle the process of actually cloning it. So first, we're going to need to make the new code iterator. And for that, the new code iterator, what is going to be called? New iterator equals new code iterator. This dot calling function. This dot function to analyze. This dot high function. And this dot current program. So the arguments that I passed a calling function to analyze, the high function, and the current program, none of those will really, they don't change anytime I really clone it, so I don't have to worry about just passing those arguments. The values I do need to worry about include, let's look this through, P codes, that's the same, don't need to worry about a calling function. Function to analyze, don't need to worry about the high function of the current program. P-code mappings, don't need to worry about that. What I do need to worry about is I and the scene indices. These are really the two different things I need to actually worry about now that I'm thinking about it. For this, what I can do is I can pass the index as a new integer, so int I, and then I make new iterator dot I is equal to I. So that solves the problem of I need the iterator to be something different. Next is a problem of needing to clone the indices. So for that, what I can do is, let's see, where is code editor is here, so I can do new iterator dot scene indices is equal to, how do I do the cloning down here? Clone 0 equals new hash set. And I can just do this dot scene indices, that way it makes a new one, and then I can just return the new iterator. So that alone, it should prevent, well, it should make it so, it should effectively clone another instance that we want. So for this, we can just do code iterator branch iterator equals make branch clone of new index, and we're going to have this if new index is not equal to -1. Cool, so we have that. We don't need this anymore, so we'll just comment it out. So we construct it, and next we just need to actually iterate through it. So dot iterate code path. Okay, there's an error. Cannot find symbol equals new code. Oh, this needs to be capitalized. Okay, cool. So it iterates. How does this iteration work? Hang on. Yeah, we see here it's int add. This is a bit weird. It should be starting from 0, this int add, then load. However, it's not. Why? I think let's also print out the index that we're seeing here. Let's see what we have here. So we start. Oh, wait, why? Oh, I get it. We start iterating from here. The reason why it does this 0 through 1, 2, 3, whatever, is it's repopulating. Let's see, what is it? The get p code index mappings. Get p codes. Start p code mappings. Where's p code index mappings being called from? Get p code index mappings. Oh, it's called right here. Okay, how can we? For now, I'm gonna leave this. I want to do a way where I could probably like not have to reiterate that, because that'd be a performance hit. Actually, I can do that right now. Let's see. Let's have a Boolean. What I can do is have this be where p code mappings is equal to null. And in iterate code path, I can just do a check if this dot p codes that is equal to null. Then I run this function. So it should only run once. And what I will do, where is this? Okay, yeah, that's where the function belongs. For making a new one, I can just new iterator dot p code mappings equals this dot p code mappings. Okay, cool. So we shouldn't have to repopulate those every time we clone or go down another branch. So let's take a look. We start from 0, 1, 2, 3, 4, branch to 7, 8, 9, 10, 11, 12. We get the call, and then we go down the other branch if the conditional is not reached. We 5, 7, 6, branch to 13, all the way until we get the call. Okay, cool. So that's there. The next step is to go ahead and try to start modeling the conditions for that. And for that, I'm going to save that for another video. This stream has been going on for 40 minutes, so I'm going to call it here. Thank you for watching and see you next time.